React is responsible to render the components and manage the component at runtime. That means React is responsible to completely manage the lifecycle of the components. During the execution of the components, React executes some predefined methods internally at different phases, and those are called as lifecycle phases. Totally, every React component contains 4 phases, that is mounting phase, updating phase, unmounting phase, and error handling phase. At each phase of the component, different methods will be executed. The developer can use those methods in order to manage the component and load the information from the server, and also make the component re-render or avoid re-rendering the component wherever it is not necessary. So it is necessary for the developer to know what methods will be executed at which phase and what kind of code can be written at each method. The mounting phase is the phase where the instance of the component is being created and rendered for the first time into the DOM. For example, you have a component called shopping cart component. When you execute that particular shopping cart component, the shopping cart component will be mounted, that means rendered on the browser. During that process, the mounting phase will be executed. As a part of that, 3 methods will be executed of your component class, that is constructor, render, component did mount. They execute in the same order as they mentioned. Every time when the property value or state is changed, the updating phase will trigger out. In this case, render component did update will be executed. And at the time of leaving or closing the application, the unmounting phase will be executed. Generally, this happens only when the routing is enabled and the user navigates to another route from the current route. Or it also executes whenever the parent component removes the instance of child component. And finally, the error handling phase will be executed whenever React identifies an error during the rendering or lifecycle method or constructor of the child component. For example, we have a shopping cart component which contains children of product components. While executing any one of the product component, it has an error. So that leads to error handling phase of the shopping cart component. Or during the render method of the shopping cart component itself, there is an error. At that moment also, error handling phase of the shopping cart component occurs. In this phase, only one method, that is component did catch method, executes. If you can check React docs, there are some additional methods that you can identify. For example, get derived state from props, etc. But those methods are noted as extremely rarely used methods by React docs itself. Here, we are focusing on only the methods that are really useful and frequently used in the real-world applications. So 90% of the times, we use these methods in the real-world applications. So, how and when we use these respective methods at different phases? We will understand about each phase by lecture in this section. First, let me demonstrate mounting phase to you. As a part of the mounting phase, the constructor, render, and component did mount methods will be executed in the same sequence. The constructor is suitable for initialization of the state and binding the event handler methods. But what you should not do in the constructor is that you should not make HTTP requests or fetch the data from database or something. In the render method, you should not update any changes to the props or state. That means you should not use set state or anything like that in the render method. But the render method should return the UI as a HTML element. And the component did mount method executes after execution of the constructor, render, and the complete lifecycle of all the children. Let me demonstrate all these three practically. So we are taking the example of shopping cart component and product component. Here, shopping cart component is the parent in which one or more product component instances are displayed like this. So this is your shopping cart component, and each box, that is each product, is an instance of product component. We have 6 products in the array, so 6 instances of product component has been rendered. So in this context, inside the shopping cart component, I am trying to add something called constructor. By definition, the constructor executes as soon as an object is created for this particular class. That is the definition of object-oriented programming in other languages. But being in React, the constructor will be converted as a function, so there is no object for this class actually, to be frank. The constructor executes when the component is mounted, that means execution started. The major thing that you will do with the constructor is initialization of the state. In all the previous lectures, we are directly initializing the state property by assigning an object literal into the state property. That is one way. The alternative way for the same is that you can initialize the same state in the constructor by using this dot state equal to something. So you can do either of these. Either outside the constructor state equal to object, or in the constructor this dot state equal to object. And moreover, the constructor is the only one place where you can directly initialize the state by writing this dot state equal to. In nowhere else, that means in nowhere other methods, you should assign the values into the state directly by assigning. That means if you try to assign this dot state equal to something in other methods such as render, it is not valid. In all the methods except constructor, you must use this dot set state in order to make updates in the state. So if you run this application now, in the browser console we are getting errors. That is, must call super constructor in the derived class before accessing this or returning from derived constructor. Which means that you must call the super class constructor inside your derived class constructor, that is shopping cart component constructor. So you should write like super. So by this statement, you are calling the super class constructor. What is the superclass here? The component class. So from this statement, you are calling the superclass constructor, that is the constructor of the component class, that is the parent class. Now that error is cleared out. And moreover, in this case the problem is that in case if someone has supplied some props for this component, that will miss out. Because the superclass constructor expects a parameter called props that must be supplied from this statement. So how will you receive the props which are supplied by some other components while invoking the shopping cart component? For example, we are invoking the shopping cart component from app.js X file. So in the app.js X file, suppose you supply some value such as x equal to 10. So this x value will be received into the constructor. So in the shopping cart component, the constructor by default receives those props, and you can initialize the same in your current working component by passing the same to the parent class constructor. So first you are receiving all the props that are supplied from your parent component, that is app component, and you are passing the same to the parent class constructor. So these properties will be initialized in the props property of the current working class. So this is the common code that you will write in every component. So it's a three-step process. First, the parent component supplies one or more props that will be received into the constructor first, and then you are repassing the same to the parent class constructor. Those will be initialized in the current working component then. In that way, the props is really available in your component. So anytime when you are creating the constructor in your component class, don't forget to call the parent class constructor by using super and also supply the props for the same. So what code should not be written in the constructor is that you should never make HTTP requests inside the constructor. The same can be made in the component did mount method, because that executes after completion of all the component lifecycle of all the child components that are rendered inside the render method. So, as a sequence of execution, first the constructor of your component executes, and then your render method of your component executes. As a part of that, in case if you invoke any other child components, for example, we are invoking some XYZ component, the complete lifecycle of XYZ component executes, starting from constructor, render, and component did mount. And after completion of the lifecycle of XYZ component and other child components, the component did mount method of your shopping cart component executes. So let me add it. After the render method, I am trying to add a method called component did mount. So this method executes after the constructor and render method of the current working component, including the lifecycle of all the child components if any used in the render method. So this method is the perfect time to make any HTTP requests to fetch data from database or any other data source. But as of this lecture, we are not making any HTTP requests to fetch data from data source. We will do that later in the further sections. But for a time being, let me add console.log messages for each place. That means in the constructor first. So console.log of constructor of shopping cart, and I am adding a console.log message in the render method. And also after that, I am trying to add a console.log message in the component did mount method of the same component. So let us see the output to identify the sequence of execution. As you can see, first it has begun with constructor of the shopping cart component, then render method of the shopping cart. All the child components have been executed. That means the complete life cycle of child components execute here. And after that, the component did mount method of shopping cart component executes. This is how do you understand the mounting phase of your lifecycle of React component. In the next lecture, we will demonstrate updating phase. Let's focus on updating phase. Whenever the props or state is changed by the developer, the updating phase executes. The props are supplied from the parent component and the state is the own of the same component itself. So whenever either of these props or state has been changed at runtime, the updating phase will be triggered out. As a part of that, the render and component did update methods will execute in the same sequence. First, the render method executes, which returns a HTML element and that is treated as a React element and that is treated as a virtual DOM. Then React compares the new virtual DOM with the old virtual DOM which was already rendered and identifies the differences or changes. If any changes are found, the corresponding changes will be updated in the browser DOM. In this case, this render method is the same which was already written in your component. But let me add the component did update method. So inside your shopping cart component, already we have the constructor. Let me minimize it for clarity. And then we have render method. And then we have component did mount method. And after that, let me add component did update method. And let's have a console.log message. And update U is uppercase. Let's test it. As you can see, first constructor, then render method, and lifecycle of all the children. And after that, component did mount method executes. Notice there is no component did update method executes here. So whenever there is some change in the props or state, then only the update phase will be executed, right? So for initial render, component did update method will not be executed. For example, let me click on this plus button to increase the quantity. So in this case, only it has executed the render method, the lifecycle of all the children, and then the component did update method executes. Let me clear the browser console and try again. So I click on the plus button, the render method of the shopping cart component, lifecycle of all the children, and then component did update method executes. So the component did update method indicates that all the children have been loaded successfully in the current working component. And in this component did update method, you have two automatic arguments, that is prev props and prev state. That indicates previous properties and previous state. And already we have the current properties and current state. If needed, you can check it out. That is this third props and this third state. So totally I am printing 4 values through this console.log. One is the message, that is component did update, previous props, previous state, that are received as automatic parameters that are supplied by React automatically, and also the current working props and state of the current working component, that is shopping cart component itself. So let's run this. Of course, for initial render, component did update method will not execute, right? So let me clear the browser console and click on the plus button for any one component. For example, let's say plus. So as a result, the shopping cart component went to update phase because there is some change in the props. That means the products array have been updated by the parent component. So in this case, the render method executes and the lifecycle of all the child components execute. We have 6 components. That's why it shows this 6 times. And then only one time component did update executes for the shopping cart component. and this is the previous props, and this is the previous state, and this is your this dot props, that means the current props, and this is the current state. And what has been really changed is that if you can verify, there is no difference between the previous props and the current props. Both are x equal to 10, but there is some change in the state. So in the first case, you can notice the products with all quantity as 0, 0 for all the products. And in the current state, expand, you can see the quantity has been changed as 1 for Samsung QLED TV. So this is how you identify the changes or differences between the previous props and the current props, or previous state to current state. Sometimes you will have a logic, that is, whenever there is some change in the particular property or particular element in the state or props, you want to make a HTTP request to fetch additional data from the server or make any other changes in the database. So, in that case, you are free to perform any kind of database operations by making HTTP requests in the component did update method. But always make sure you make HTTP calls conditionally but not unconditionally in this method. That means we have to check. For example, if previous props dot x equal to current props x value, then I don't want to make any HTTP call. If it is not equal to the x value, then I would like to make a HTTP call. So I should make HTTP call only when this condition is true, but not unconditionally. In case if I make HTTP call unconditionally without checking any condition, it leads to performance issue because this method will be executed for each change in the state or props. In a real-world application, the state will be updated many times from various buttons or various clicks of the user. For example, your real-world application may consist of various buttons such as filtering, sorting, delete, new, etc. For each button click, the state may be updated, and each time the state is updated, the component goes to updating phase, and for each time this component did update method executes, right? So if you make HTTP call unconditionally, for each updating phase, a HTTP request will be sent to the server, so it will be a performance issue. So that is the reason it is not advisable to make HTTP calls unconditionally in this method. But if you have a proper reason or logic, you can check your condition. If the specific condition is true, for example, if the user has entered this particular input value, then only you will make HTTP call in this component did update method. Otherwise, it is better to avoid such a HTTP call if you don't require so. So anyways, currently as per our application, we don't require an HTTP call in this case. So this is how do you understand the updating phase of the lifecycle of the component. Now let's focus on unmounting phase. In this phase, mainly one method will be executed, that is, component will unmount. This phase will be occurred before leaving or deleting the current instance of the component. Generally, this occurs when the user navigates to another route in case if routing is enabled, or when the parent component deletes the current instance of the current working child component. So in either of these cases, the component will unmount will be executed. And you will use this component will unmount method in order to unsubscribe, that means cancel the HTTP requests if any. So overall, you will place your cleanup code to cancel the HTTP requests in this method. Let me demonstrate this. So presently this condition is not required for us. Let me comment this out. And let me add the message called component did update for shopping cart. That is in the component did update method. So this particular component will unmount method will execute before deleting the current instance of the component, that is shopping cart component. In this method, let me add console.log message component will unmount for shopping cart. So let's run this. When the page is refreshed, that is called mounting phase. In that case, the constructor, render, the child component lifecycle, and component did mount method execute. After that, whenever some state or props has been changed, for example, I click on plus button, the render method, the lifecycle of all the child components, and then component did update methods execute. After that, when the user navigates to another route, for example, if the routing is enabled, the user clicks on another hyperlink in the navigation bar. In that case, component will unmount method will be executed for the shopping cart. But as of this stage, we have not enabled routing in this application, right? So that is the reason it doesn't trigger component will unmount method. But let me demonstrate the same for product component. So let's copy the same method into product component. So in the product component, after the render method, I am pasting the same. And let me make this as component will unmount for product. And let's run this. And let's clear the browser console. Now let's delete any one child component instance. For example, I click on close button or delete button for the Sony camera. And I say yes. As you can see, the component will unmount method has been executed for the product component because that specific instance of the product component has been cleared out. And after that, update phase has been executed for the shopping cart component. So it doesn't trigger component will unmount method of the shopping cart component. It executes only when the routing has been changed or the component has been removed by the parent, that is app.jsx file. This is how do you understand unmounting phase. What kind of code will you write in this component will unmount method? You can write some cleanup code to cancel HTTP requests if any. This is how do you understand unmount phase in the component lifecycle.